Now, what is that kind of bonding? Is it intra, within one, or is it in between water molecules, inter? So what kind of intermolecular bonding occurs in water? Hydrogen bonding. I didn't name it, but somebody named it hydrogen bonding. Now, hydrogen bonding, even though it's weaker than covalent bonds, what if you had 1,000,000 hydrogen bonds in a drop of water? If you had, a couple million hydrogen bonds, that would really hold it together, wouldn't it? And water is really not supposed to be a liquid. It's not supposed to be a liquid at this temperature. But hydrogen bonding doesn't allow them to escape and turn into a gas. And that's why we have water that goes from 0 all the way to 100. Water has a high boiling point for its size. And that's because of that hydrogen bonding. All right. What else about this page? Anything else about this page? What about an alcohol? An alcohol is made of carbon, hydrogen, oxygen, so that would be covalent bonds, wouldn't it? But look at the structure. OH. Uh-oh. What happens when O and H want to share a pair of electrons? Who always gets them more often? The oxygen, doesn't it? Okay, so then this part of the molecule becomes slightly negative, and the hydrogen becomes positive. So guess what? Water is a polar molecule, has a plus and minus end. And what about alcohol? Polar or not polar? It is polar. Why? Because you have uneven sharing right here. So does alcohol mix with water? Yes, because polar things have a plus-minus nature. They can dissolve things that also have a plus-minus nature. What about over here? Does water dissolve many ionic compounds? Yes. Why do they call water the universal solvent? It dissolves a lot of things, doesn't it? So what is the nature of an ionic compound? What's it made of? Starts with I. Ions. It's got a plus-minus nature, doesn't it? What about water? It's got a plus-minus nature. So water likes to dissolve a lot of ionic compounds. And here's a covalent compound, but it also has what? Hydrogen bonding, right? It's polar, I should say. It's polar. And so that would also be able to dissolve things like alcohols. Yes?
So that's covalent, but it's also polar?
It's covalent, but because the O and the H don't share evenly, just like in water, it becomes a polar, and that means it has a plus-minus nature also. And then what about table sugar, which I'll never have you memorize that structure. That's too big. But table sugar is C12H22O11. But take a look. OH, OH, OH. See that? That's uneven sharing. So that's going to be have a plus-minus nature here and here and here and here and here. So does table sugar dissolve in water? Yes. Okay, so you see water can dissolve a lot of things. And the last one I'm going to show you is what are hydrocarbons made of? Remember candles are hydrocarbons? Why didn't a candle mix with water? Because it's only made of what? What's a hydrocarbon made of? Hydrogen and carbon. And when they share electrons, it's very even. It's very even. And so we don't get a plus and minus nature there. So what do you call a molecule that does not have a plus minus nature? Non-polar. Is that right? Okay, so gasoline is only made of C and H. Candle wax, C and H. Vegetable oil, C and H. That's why they don't mix with water. What do you think? Pretty good? And let's go all the way back now. Let's go back all the way back to the chapter we're actually working on. And I'll show you one more page here, and then we'll move on to what I really want to show you today. Yeah, yes.
Like when the liquid wax is like in the little thing of the candle, that doesn't have any water in it. It's just
Okay, now, some of you tried that. Some of you actually put water in there, didn't you? And what happened is it wouldn't mix, but then the water went to the wick, and the water got drawn up the wick, and it put your flame out, didn't it? As a matter of fact, you had trouble relighting it because it was wet. It had real water in it. What would we want to have be in the wick? Not liquid water. We wanted liquid wax to be in there. So they didn't mix, and so now that's a good question about when you put water in there. Wax is actually less dense than water, so when you put water in there, I bet the water must have got underneath there, but somehow it got to the wick. I went up like that. That's a good question, yeah. All right. Wrong page. Okay, now, there was one page. Where is it? And for whatever reason, I'm not sure why the author stuck that page right in the middle of the other lesson he had there. But this is actually easy now. This is kind of easy now. Imagine having a battery, a nice battery, and you have a wire or an electrode, and then you have a light bulb in here. And I wouldn't use a big light bulb, just maybe an LED light or something like that. What would happen if I touched this electrode to that electrode? It would make a complete circuit and light up the light bulb, wouldn't it? But what if I put the electrodes in water? What if I put it in pure water? Will the light bulb come on? And you say, well, what's pure water made of? It's made of H2O, isn't it? That's all. That's the only thing that distilled water is made of, is H2O. Are there any ions there to help carry the charge? No, because it's not an ionic compound. What kind of compound is it? Covalent. All right, so pure water would not conduct electricity. And I did this one other day. I did a demonstration. What about tap water? Is there something else in there besides water? Yes. And it costs a lot of money to take everything out of it, so they don't. And they have studies showing it's okay. You got a little bit of iron there, you got a little calcium in there, right? What form is that in? What form are calcium and what ions, aren't they? We can't see them, can we? But anyway, tap water is an electrolyte. It does conduct electricity. Let's do another one. What if I put some table salt in distilled water? Distilled water does not conduct electricity, but what happens when I put salt in water and dissolves? It also does what to the ions? Breaks them apart. Now you got ions coming out. Will that carry the charge from one electrode to another? So what do you think about salt water? Electrolyte or not? It is. All right, how about sugar water? Put that in there. Stir it up. It dissolves because it's polar, but does it break up into ions? And you say, how do you know? How do you know it doesn't break ions? Because it's a non-metal. It's not made of ions, is it? It's not made of ions to begin with. What are ionic compounds? Metal, non-metal, or positive ions and negative ions. All right. See okay on that? Pretty easy? And again, I'm not sure why I put that right in the middle of all the other lessons, but I just... Okay, do you know that acids and bases, by definition, they are solutions that contain hydrogen ions, don't they? You know what an acid is? And the bases contain hydroxide ions. So, of course, all acids and bases are electrolytes. I remember one time, it's kind of weird, but I don't know if you've ever had to do this. You probably never have, but if you have a house that has wallpaper, and let's say you just think, that is some ugly wallpaper, or I just need to take that wallpaper down. How do you take wallpaper off a wall? Have you done that? Mm-hmm. What do you have to do?
You steam it?
Yeah, you steam it. You can buy this thing and steam it, and the heat will try to melt the glue on the back of there, and you can hopefully peel it off. And sometimes that works. What happens if you don't want to get a steamer? Is there another way? Well, there's another way to do this. You can actually buy this spray, and this spray seeps through the wallpaper into the glue, tries to dissolve the glue, and then that's another way to do it. Now, I learned one way. What's interesting one day is I was spraying like that, and there was a wall outlet. I didn't think a whole lot about that, and I sprayed it, and then I touched the wall. You ever feel electricity? What's going on here? And so what's happened, that made a continuous little film of that spray. What do you think that spray might have in it? It starts with I.
Ions.
Right, and when we got to the electrical box, it was conducting electricity like that. So anyway, I learned to have to be careful when I turn the electricity off. I'm going to use that stuff. All right, you okay on this? All right, now let's see how well. All right, here we go. Let's go to page 173. Now, if I do give a quiz on Friday, it'll be something like these. Look at these three questions here. And what I'd like to do is I'd like to show you how to do this and so you feel confident about it. Take a look at A. It says here, using the solubility rules, and I'll give you a chart, what do you think will happen when you mix these two aqueous solutions, all right? Now, we can sit there and write the entire equation out like we did yesterday, or we can be smart about this, okay? Can everybody, does everybody understand that these are double replacement reactions? Yes or no?
Yep.
Okay, so guess, who can I call on? I don't know. Tim, ready? Tim, what were the two products be here? What are the two products? Just say them out loud.
Is it K?
Just say the word, and then we'll talk about the equation, or the formula later. Give me the name of the two products.
Potassium chloride
Yes,
and barium nitrite.
nitrate. Excellent. Okay, now, look at me, and what are the two products in? Potassium what? Chloride, and you can look it up, or you can remember the shortcut. What do you know about all potassium salts? They're all aqueous, so they're not going to form a precipitate, are they? What about the other one? What'd you call it? Barium what? And we can look it up, can't we? Or you can save a little time remembering that all what?
Nitrate.
All nitrates are.
Aqueous.
So guess what? When I put these two together, nothing's going to happen. Nothing. Let's do the next one. Let's do B. Who can I call on here? Abby. I don't call on you enough. Sorry, Abby. Abby, tell me in words, what are the two products that would happen in number B?
Sodium.
Real loud.
Sodium nitrate.
Yes.
Lead sulfate.
Lead sulfate. Which lead? Lead 2? Lead 4? Lead what?
Lead 4.
How do you know that?
Or lead 2. Because sulfate is like -2.
Yeah, but look at okay, yeah, look over here. Nitrate's -1, isn't it? And how many nitrates do they have? 2. So that's -2. Then this lead must be what?
2.
+2. So it's lead 2. So the other one is lead 2 sulfate. Is that correct? All right. What do you think, Abby? What do you think about the first one, sodium nitrate? Is it going to be a precipitate? And you can look it up, or you can remember that all sodiums and all nitrates are soluble, so it's not going to be a precipitate. What about the other one, lead 2 sulfate? Let's go look it up. Lead 2 sulfate. And right there. Oops, right here. What does S mean here? It means
Solid.
it's a solid, which means it's going to be insoluble. So, is this reaction going to take place?
Yes.
Yes.
Yes, because the driving force, the formation of a solid. All right, so now what I want you to do is I want you to see if, not necessarily in your book, but can you write this out, this equation out? So we know what's going to happen. Here's what's going to happen on the test and the quiz. I'll say, if a precipitate forms, write the formula of the precipitate. So here we go. Is the precipitate going to form here on number B? Or what is the formula for that precipitate? What's the name of it, first of all? Lead 2 sulfate. Well, how do you write that formula? How do you write lead 2 sulfate? Some of you, a little disappointing on the exam, you still are missing how to write formulas. That's a skill you have to have, and you got to get better at it, okay? We're going to do the next 4 chapters. We're going to be writing formulas. All right, so here's lead 2. What's sulfate?
That's so cool.
And that's -2, isn't it? So, on the quiz or test, if it says, if a precipitate forms, write the formula of the precipitate. What are you going to write? You're just going to write that there. That's all I want. See that? Let's do the next one. Number C. Zoe, ready. What are the two products in, just tell me in English.
Potassium nitrate.
And is that going to be a solid? Is it going to be a precipitate? And you can look it up, or you can remember that potassiums and nitrates are all soluble, right? What about the other one? Iron what? Just a little bit louder. Right. So this was iron 2 nitrate, wasn't it? And that'd be iron 2 hydroxide. Okay, now we're going to look that up. Let's look that up. Iron 2 hydroxide. What's that say? It's going to be a solid, isn't it? So is this reaction going to take place? Yes. So if I ask, if a precipitate is formed, write the formula for the precipitate, what would you write? How do you write out the formula of the precipitate? Say it again. Fe. Zoe, what's the name of the precipitate? Then we'll write the formula. Real loud.
Iron 2 hydroxide.
All right, how do you write iron 2 hydroxide?
Plus 2.
So don't we have to have 2 hydroxides? Okay, did everybody got that? Yes, no?
Yes.
Okay, yes.
Is it 2 because of the hydroxide?
Yeah, this was iron 2. That means it's plus 2. But what's the charge on hydroxide?
That was iron 2.
Minus 1. Hydroxide is minus 1, right?
Yeah.
Wait, did I make a mistake? Does that say 3?
Yeah.
Oh, my fault. Ah! Your fault. No, my fault and your fault. That's a 3. My eyes didn't see that. This is iron 3 nitrate, so this has to be, good catch. This has to be iron 3 hydroxide, so now I need 3 hydroxides, don't I? Thank you. Thank you for that. I gotta watch my eyes. All right, what do you think? Iron 3 hydroxide. All right. Okay. So what I'm going to do now is I'm going to go to page 175. Let's go to page 175 and take a look at A there on self-check. How fast can we do this? Do you think this reaction is going to form a precipitate? And it's double replacement. So what are the products going to be?
Which one is this?
A. You have what? Barium what? Chloride, and what? Okay, now which one you probably don't have to look up because you said it about 6 times. Sodium and nitrates are all soluble, aren't they? But now, what about the barium chloride? Let's take a look at barium chloride. What do you think about barium chloride?
It is aqueous.
Ah, so guess what?
No reaction.
No reaction takes place. Now, what I'm going to do is I'm going to show you another skill that we have, and I'm going to do B. And so let's take a look at B. No, that's not a good one. Let's do C. Sorry. Oh, yeah. Okay, do C. Now, let me show you what's going on here. This is a skill that I want you to have. Now, for whatever reason, the author likes to call this the molecular equation. I don't know. I wouldn't call it that. I'd like to call it just a plain old chemical equation. But the author likes to call it the molecular equation. I'm on page 175. Wait, 175, yeah. Okay, so what I want to do is I'm going to ask you to write out the molecular equation, and we've done that. We've had a whole chapter on that. So here we go. We know it's double replacement. Okay, so, who haven't I called on? Bronwyn. Ready? Give me one of the products. Oh, by the way, this was aqueous and this was aqueous. So on the test, I'm gonna make you put these little symbols here, okay? So two solutions. A solution of ammonium chloride is added to a solution of lead 2 nitrate. And tell me, Bronwyn, what's gonna happen?
Ammonium nitrate.
Okay, now how do you write the formula for ammonium nitrate?
There'd be
What's ammonium?
or minus 1 or plus 1, and then
Nitrate?
nitrate is minus 1.
Well, then I think we're done on that. Okay, now we'll find out. Now, what do you think comes after this?
Lead
S or AQ? And you can look at the chart, or you can remember what? All nitrates are soluble, all ammoniums are soluble, so we're going to put AQ after this, right? All right, Brandon, what's the next one?
lead chloride.
Which lead chloride?
Lead
What was the charge on lead here?
plus 2.
It was lead 2, wasn't it? Okay, so we have lead 2 chloride. How do you make lead 2 chloride? Is that going to work?
You do 2 chloride.
All right, everybody okay? All right. Now, let's take a look at this one. Look at the chart and tell me what you think. Aqueous or solid?
No, solid.
Are you sure?
Yes.
What do you call an insoluble product? Yes, 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 precipitate. Very good. All right. So, we're going to put S after this, aren't we? And guess what? Ding, ding, ding. That's my driving force. That's why the reaction is going to take place. All right. Now, let's balance it. You're supposed to be good at this by now, okay? Some of you still, I'm telling you, on the exam, you have to disappoint yourself a little bit, but we balance equations a lot. And I understand on the balance equation on the exam, there was maybe 1 out of the 6 that were harder, but some of you missed 4. You missed 4 balancing equations. Something's wrong. I can help you fix it. All right, let's balance it. Ready? 2 nitrates, 1 nitrate. 2 ammoniums, 1 ammonium. 2 ammoniums. 2 chlorines, 2 chlorines, 1 lead, 1 lead. What do you think? All right. Now, here's something you have never done, ever. This is the longest equation you'll ever write in your life. It's called a complete ionic equation. By the way, there's a vocabulary word for you, isn't it? And again, it's on page 175. It's in dark print word, complete ionic equation. Now, sometimes I don't really slap them on the wrist, but even my seniors who were in second year chemistry, they still make a mistake here because they look at their eyes instead of using their mind. And what I want to do here is I'm going to ask you, what's in this beaker? And you have to think. That's what makes this chapter a higher level chapter. What is in this beaker? I'll give you a clue. It starts with an I. Okay, now here we go.
Oh.
What's going? Okay, ready? What is in this beaker? Are you ready? What's in this beaker?
Ion.
How many?
2.
21.
Be careful. This is going to be the longest equation you've ever written in your life. Ready? What's in that beaker? For every 2 ammonium plus 1 ions, you'll also find what? 2 chlorine minus 1 ions. And what's going to be in this beaker?
Oh.
Use your mind, okay? What is it? What kind of lead?
2.
Lead plus 2 ion, which is surrounded by water, plus, be careful, don't use your eyes, use your brain.
2 2
Say it.
2 nitrates.
How do I write it?
In the same
Do
way.
I write NO3 with those 2 down here?
No.
No.
Nope. No, sir.
What is it?
2NO3.
Isn't that what it says? There's 1 of those ions and 2 of those ions. Isn't that what it says?
Yes.
Okay. Don't put diatomic nitrate in there. Okay. Now we're not done yet. That's only the second half. That's only the first half. Now, are you ready? What are we going to put here? What's in it? What's here? What's in the when the reaction's over? What's going to be in there?
Two. River.
Yes, that.
Okay, we're getting there. We're getting there. Now, do you know how to finish it?
Do I?
Do you know how to finish it?
Ah.
Do you know how to finish this? All right, raise your hand if you think you know how to finish the complete ionic equation. Who wants to take a chance? Take a chance. What am I going to write now? Reese, you can do it, Reese. Okay. All right, Zach. How do I finish this?
Just PB.
Plus PV plus 2 plus 2 CLA2.
Good chance. I'm glad you took a chance. I'm going to say no. Yes?
Do you do plus PVCl2S?
Yes.
What?
Now, you know what?
I'm sorry.
You know why I broke these up? Why did I break them up in ions? Because what?
They dissolve.
Ionic compounds that are dissolved in water. And what about this one? I broke it up, didn't I? What about this one? I broke it up. What about this one? No.
No.
They're not dissolved in water.
No.
As a matter of fact, if you don't write like this, wait. If you don't write this, you have no driving force. That means the reaction didn't take place.
I'm sorry.
How'd you know that? How did you know that? I didn't expect anybody in this class to get that.
Because
Wait a minute. Listen.
It said complete ionic equation. Those were ions. That was just ions.
They are ions, but they're not.
Yeah.
But the ability. Wait a minute. Wait. The ability of lead to attract chloride is greater than the water's ability to pull them apart. All right. Next. Watch now. This is the fun part. Okay. Now, I need your attention. All right. We're almost done here. What time is it? I got to have enough time to do this. Okay, yeah, I got time. All right. The next thing I'm going to ask you to do is write not the complete ionic equation. That's really long, isn't it? But now we write the net ionic equation, and the way you do it is you cross out spectator ions. And I'll show you what those are in a minute. And it's in a book. It is in a book. But let me show you how to do that. If I went to a soccer game and I was on the field, I would not be a spectator. I'd be definitely involved in the game, wouldn't it? But somebody who's not involved in the game is just watching there, and they had no effect on the game in a sense. They didn't kick the ball, they didn't pass the ball, they didn't do anything like that. So watch. Spectator ions are ions that before the reaction took place are exactly the same way they were after. They did nothing. So let's take a look. You see these two guys, two ammoniums? They were floating around the beaker, weren't they? What happened after the reaction? Oh, whoa. Oh, get out of here. You're a spectator. Now, who else is a spectator? Who else is a spectator ion? How about you? Oh, no. How about lead?
Yeah.
Oh, no. How about this?
Nitrate.
As a matter of fact, wait a minute. If you'll listen carefully, if they had a 2 here and you only had a 1 here, it kind of told you didn't balance the equation. It gives you, it'll catch your mistakes. You get it? If I see 2 nitrates here and only 1 here, I probably made a mistake, because that's a spectator ion, isn't it? All right, now, what's the net ionic equation? Here is the only chemistry that took place in those beakers. 2 chloride ions that were dissolved in water reacted with what?
PB.
Lead 2 ion, and formed the solid called lead 2 chloride. That is the only chemistry that took place. I had a lot of chemicals there, but only these chemicals actually were involved in the reaction. Is that pretty neat? Yes?
So that's just one question, right?
Now, the biggest mistake, why is it that people make mistakes when I ask them to do this? I'll have you do this on the test, but take a look right here. When I ask them to do the complete ionic equation, they look with their eyes so much. They'll put PB, and they'll forget to put +2. It really is an ion. That's a mistake. And then they'll put NO3 with a subscript 2, like, what is that? What's diatomic nitrate? I don't know what that is. All right, so anyway, same thing. All right, so that is, I would like to show you, that's how you do it the long way. Now, everybody should be able to practice the long way. I will ask you on a test to do the long way. You get that? But I want to show you, I got about 2 minutes here. I'd like to show you how to do a shortcut. Maybe you're not ready for a shortcut. Let me think about this.
I think we're ready.
Okay. Okay, let's take a look right here. And here's an equation that says sodium chloride aqueous reacts with a solution of silver nitrate. And so what I'm going to do here is I'm going to show you how to do the net ionic equation without having to go through all that. So are you ready? Here we go. We got about a minute. We can do it. NaCl aqueous plus silver. Wait a minute. My fault. Yeah, NaCl plus silver nitrate. NO3 +1 -1 aqueous. All right. Now, yes, will I ask you to do this? I will, just to show me you can do that skill. But I would love to show you how to do a shortcut to get to the net ionic equation. Now, it's kind of a neat little trick. I only have about 1 minute to go. Ready? In words, tell me the 2 products. In words. Sodium nitrate,
And
silver chloride. Now, do anybody happen to know about sodium nitrate?
That's
Yeah, sodium.
aqueous.
You will not form a precipitate. What about silver chloride? In fact, silver chloride is one of the most famous precipitates in all of chemistry. It's a white, very bright white precipitate. But you can look it up, and what's it say?
So,
Now watch, I'm going to do this backwards. Watch now.
no,
What's going to be formed?
silver chloride.
And that's going to be a solid, isn't it? Now, watch. What's the only way you could have made that?
Cl and silver.
Done.
Done.
Wow.
It's easy.
I went backwards. I did an equation backwards. We'll review that again tomorrow. Do you know that packet I've been giving you? That thing is due on Tuesday. So what you want to do is maybe go home and say, how much of that can I already do? You got that? Hey, you did a great job today. Great job today.